Think of running a complex computer program exactly like launching a multi-billion-dollar space mission. Listen, when you're sending a rocket into orbit, there is absolutely zero margin for error. Every single calculation must be perfect. But what happens if an anomaly occurs? A tiny sensor misreads data or a thruster misfires. Your systems need to handle that safely rather than crashing the whole mission into the ocean. This is exactly what exception handling is all about in computer science. Mastering exactly when and how to use exception handling is absolutely critical for your Cambridge computer science success. Whether you're studying syllabus 417, 478, 0983, 0984, 2210, or especially the advanced AS and A-level 9618, this concept is everywhere. In fact, this topic appears in every single examination series. It's literally a non-negotiable skill if you want top marks. So today, we're going inside the examiner's mind to look at exactly what they are expecting to see on your paper and how you can guarantee your code is ready for launch. But right off the bat, here is the central mystery we are going to solve today. Why do well-prepared candidates, students who clearly know their stuff and have studied for months, still fail to secure top marks? Well, according to the principal examiner reports, we consistently see two specific types of candidates missing out on easy grades. Let's call our first student Alex. Now, Alex overloads every single answer with massive paragraphs of raw computer science facts, but provides zero actual analysis. It's just a brain dump. Then we have our second student, Sam. Sam constantly rushes against the clock and completely misses the command word requirements in the question. Both Alex and Sam know how to code, but they completely fail because they don't know the exam. They don't know how to play the game. So to make sure you don't make their mistakes, here is our exact flight plan for today's session. 1. Core principles and theory. 2. The method mark strategy. 3. The procedural framework. 4. Evaluating algorithm quality. And 5. Avoiding top examiner traps. Let's get straight into it.
Starting with Section 1, Core Principles and Theory.
Here's the truth. Examiners aren't just looking to see if you can memorize a bunch of syntax. They're actively targeting very distinct cognitive domains. Yes, they absolutely want to see your foundational knowledge and understanding, but they demand application and analysis. You need to demonstrate a systematic analysis and evidence-based reasoning when you're deciding why a specific block of code requires a try-catch statement rather than just some basic validation. This is where you need to apply the PEAL framework: point, evidence, explanation, link. Top students structure their answers this way. They make a point about exception handling, provide evidence from the scenario, explain how the mechanism catches the error, and link it back to the system's safety. If you aren't analyzing, you aren't scoring. So what really separates a decent student from a top-performing grade A student? It's connected, conceptual understanding that transfers to unfamiliar contexts. It's treating computer science like a giant, interconnected puzzle. The syllabus heavily emphasizes this. In fact, principal examiner reports specifically highlight that candidates who reference cross-topic connections achieve significantly higher marks. You aren't just writing an isolated exception handler in a vacuum. You need to show how you are integrating it with file processing, complex data structures, or network protocols. If a network packet drops, how does your exception handler deal with that specific data structure? That's the level of connection they want to see.
Which brings us nicely to Section 2, the method mark strategy.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, the most crucial point of this entire strategy phase is this concept right here. Marks are awarded for the process. When you're tackling complex problem-solving questions from past papers, if you just jump straight to the final line of code or just write down the final output, you are leaving so many easy points on the table. Examiners want to see you're working out. They want to see the analytical framework you use to arrive at your solution. The process of problem-solving is often just as valuable as the final answer itself. Show them how your mind works.
Now we move to the execution phase. Section 3, the procedural framework.
This is your computer science success blueprint. If you want to transform your answers from red pen marks to green check marks, here are the 5 logical steps you must follow every single time. 1. Deconstruct the question. What is the command word? Are they asking you to identify, describe, or evaluate? 2. Extract the relevant data from the scenario. 3. Select your analytical framework. Like we talked about, use PEAL for those extended written answers. 4. Execute your solution with incredibly clear notation. And 5, present it all with the correct terminology. This exact sequence is how you systematically fulfilled that method mark strategy we just discussed. If Sam had used this, he wouldn't have missed the command words. If Alex used this, he would have actually analyzed the data instead of just info dumping.
Now, applying algorithmic thinking within this framework requires you to completely break things down. Step-by-step decomposition is your absolute best friend here. You must also select the appropriate data structures, implement efficient code, and plan for rigorous testing. Seriously, if you are writing an exception handler, you have to prove to the examiner on paper that you've already thought about how to rigorously test it. How will it behave under pressure? What inputs will trigger it?
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's dive into Section 4, Evaluating Algorithm Quality.
Once you've written your solution using the procedural framework, your job isn't done. You have to evaluate it. Imagine you're doing a rapid data scan of a complex system chart. The syllabus explicitly requires you to judge an algorithm's quality using specific metrics. First, you must be able to identify its time complexity. How long does this handler take to run as the data scales up? Second, you need to know its space complexity. How much memory is this consuming? You absolutely must identify edge cases. And finally, evaluate the overall effect on performance. If your exception handling adds massive processing overhead to the system, you need to state that explicitly in your exam answer. Always remember this fundamental problem-solving loop. Deconstruct, solve, evaluate. First, you identify the given information and break it into logical steps. Then, you solve it systematically. Finally, and this is where students lose marks by skipping it, you evaluate. You check your answer for reasonableness and make justified recommendations. If an algorithm is inefficient, you need to tell the examiner exactly why and recommend a better approach. Imagine doing a speed writing challenge right now. Could you write one perfect Peel paragraph explaining why an algorithm failed your evaluation? That's the standard you need to reach.
Let's move to the climax of our explainer today. Section 5, Avoiding Top Examiner Traps.
Listen closely, because there are exactly 3 consistent mistakes that cost students easy marks year after year after year. Let's make absolutely sure you aren't one of them. Mistake number 1. Students completely forget to check for overflow and edge cases, particularly when they are interpreting complex binary representations. The solution? Deliberately check those edge cases every single time. Mistake number 2. Ignoring boundary conditions. You must physically test the boundaries of your data types in your head or on scratch paper. And mistake number 3, giving generic answers. This is huge. Your solutions must be specific to the context given in the question. Let's say the exam question is about a temperature sensor in a nuclear reactor. Your exception handling answer must reference that exact reactor scenario. Do not just write down a generic textbook definition of an exception. Apply it to the nuclear reactor or you will lose the marks.
And look at this. This is a massive examiner alert straight from the source reports. Candidates consistently confuse key terminology. The solution is incredibly simple, but it gets easily forgotten when you're sweating under exam pressure. Always define terms before using them in extended responses. Do not assume the examiner knows what you mean by a specific type of exception or data structure. Define it clearly and then apply it to your reasoning.
To really lock these crucial definitions into your brain, use a memory hack. Create a mnemonic using the first letters of key terms related to exception handling. This simple trick ensures that when you're staring at a blank exam page, feeling the pressure, you can instantly recall the structured points you need to hit for maximum marks. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
So, as we wrap up, I want to leave you with this provocative question to challenge everything you've learned today. If a single boundary condition fails, how resilient is your entire algorithm? Take that thought into your very next practice paper, apply the method mark strategy, and ensure your code is truly unbreakable. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.